the universal law. Every journey, whether on land, through water, or into space, starts with a simple rule, Newton's third law. Push something one way, and it pushes back, propelling you forward. This fundamental idea has powered all our vehicles for centuries. Propelling by pushing mass, every propulsion system we use today works by ejecting mass in one direction to move in the opposite direction. From jet engines to rocket thrusters, the basic idea is the same. Move mass, and you move yourself. Fluid propulsion. Explained, in air and water, propulsion means pushing against a fluid. Propellers and jet engines work by accelerating air or water backward. The reaction force propels everything from airplanes to submarines forward. Rockets in space. Space presents a unique challenge. There's no air or water. Rockets rely solely on ejecting mass, which means carrying massive amounts of fuel. This is why space missions require such complex fuel management and staging. Land propulsion, the role of friction. On land, propulsion isn't about pushing a fluid, it's about friction. Cars and trains move forward because their wheels push against the ground. The static friction between tire and road provides the reaction force needed to drive forward. The challenges on ice. Imagine trying to walk on perfectly smooth, frictionless ice. You wouldn't move effectively. The same goes for vehicles. Without friction, a car's wheels simply spin without gaining traction, which is why icy roads are so dangerous. Transitioning to theoretical frontiers. While current propulsion methods depend on pushing mass, whether fluid or friction, scientists are exploring ideas that might bypass this need entirely. Let's dive into some of these theoretical systems that challenge conventional physics. Introducing the EmDrive. First up is the controversial EmDrive. This device claims to generate thrust by bouncing microwaves inside a specially designed cavity, without any propellant. If proven, it could allow spacecraft to move without carrying heavy fuel loads. The EmDrive. How it's supposed to work. The idea behind the EmDrive is to create an uneven distribution of radiation pressure inside a closed cavity, resulting in a net thrust. But this concept appears to contradict Newton's third law, leaving scientists divided over its validity. The EmDrive's challenges. Despite some intriguing experimental results, the EmDrive faces enormous hurdles. Its thrust levels are extremely low, and reproducing results has been difficult. The debate continues as researchers struggle to reconcile it with established physics. Quantum vacuum thrusters, a leap into the quantum realm. Next, we explore quantum vacuum thrusters. This concept seeks to harness the energy of the quantum vacuum, the constant flurry of virtual particles in empty space, to produce thrust. It's a bold idea that could redefine propulsion if ever realized. Challenges of quantum thrusters. Quantum vacuum thrusters are highly speculative. Extracting usable energy from the quantum vacuum remains a huge scientific challenge. To date, this idea is more theoretical than practical, with no working models to prove its feasibility. Negative mass propulsion. Theoretical oddity. Another fascinating concept is negative mass propulsion. In theory, if a form of matter with negative mass exists, it could respond to forces in unusual ways, moving toward a push rather than away. This could open the door to entirely new modes of travel. The mystery behind negative mass. The idea of negative mass challenges our understanding of physics. Although some theories predict its existence, negative mass has never been observed in nature. Until we can detect or create it, this concept remains purely theoretical. Warp drive, bending spacetime. Perhaps the most famous speculative idea is the warp drive, notably the Alcubierre drive. Instead of moving through space, it would warp spacetime, contracting it in front and expanding it behind, to effectively transport a spacecraft across vast distances. the mechanics of the warp drive. The warp drive concept doesn't require traditional thrust. Instead, it manipulates space itself. However, it relies on the existence of exotic matter with negative energy density, something that has never been confirmed to exist in our universe. Overcoming the limitations, all these speculative propulsion systems, EmDrive, quantum, thrusters, negative mass, and warp drives, aim to overcome the limits of conventional propulsion. They promise the ability to travel farther and faster, but each faces significant scientific and engineering challenges. Fluid versus solid surface propulsion. While we've discussed propulsion in fluids, air, and water, vehicles on land move differently. Instead of pushing against a fluid, they rely on friction between their wheels or tracks and the ground. This friction is key to their movement. How friction propels land vehicles. In land vehicles, torque from the engine turns the wheels. These wheels push against the ground, and thanks to friction, the ground pushes back with an equal force. It's this interaction that moves the vehicle forward, demonstrating Newton's third law in a very different environment. Recap of today's propulsion. To recap, all modern propulsion, whether in fluids or on solid surfaces, relies on Newton's third law. Fluid propulsion pushes mass backwards, while land vehicles depend on friction with the ground. Even in space, rockets must eject mass to move forward. The quest for a new approach. Despite our success with traditional methods, the high cost and limitations of carrying fuel push scientists to search for new ways to move. Could there be a method to propel vehicles without expelling mass? This quest is driving research into some of the most radical ideas in physics today. Conventional versus theoretical. A comparison. Conventional propulsion is tried, tested, and grounded in everyday physics. In contrast, theoretical methods like the EmDrive or warp drive challenge our understanding of the universe. Each holds its promise, but also its own set of challenges and mysteries. Overcoming scientific barriers. The road to breakthrough propulsion is filled with scientific obstacles. Extracting energy from the quantum vacuum, harnessing negative mass, or warping space-time requires advances in physics that we're only beginning to explore. The challenge is not just engineering, it's redefining what's possible. The future of space travel. If any of these theoretical propulsion systems become a reality, the future of space travel will be transformed. Imagine spacecraft that don't need to carry massive fuel loads, or even vehicles that can traverse vast cosmic distances in the blink of an eye. Impact on Earth-based transportation. Beyond space, advanced propulsion methods could revolutionize land and air travel here on Earth. From ultra-efficient electric vehicles to silent, frictionless transit systems, the way we move could be reshaped by these breakthrough ideas. Integrating innovation with reality. Today's propulsion systems, rooted in Newton's third law, have served us well. But integrating innovative theoretical ideas into real-world applications will require collaboration across disciplines, from physics to engineering and beyond. The path ahead. The journey to next-generation propulsion isn't just about overcoming engineering challenges. It's about expanding our understanding of physics. Every breakthrough brings us closer to technologies that once belonged only in science fiction. Realizing the vision. While many of these ideas are still theoretical, each represents a step toward a future where our vehicles can travel farther, faster, and more efficiently. The dream of propelling without the limits of conventional thrust continues to inspire bold research worldwide. Reflecting on the journey, from the basic push of Newton's third law to the revolutionary ideas that challenge it, our journey through propulsion is a testament to human curiosity and ingenuity. Each new concept, whether practical or speculative, drives us to push the boundaries of what's possible. Final thoughts and call to action. The future of propulsion remains an open frontier. As we continue to innovate, one thing is clear: our quest to move beyond conventional limits will forever propel us into the unknown. Join us on this journey. Subscribe, share, and stay tuned as we explore the wonders of science and technology.
Subscribe to Ai-sci-fi.